Hello students, welcome to MK Academic Solutions. So myself D. Chinna, I am the faculty member of MK Academic Solutions. So in this video we are going to discuss about the chemical kinetics chapter, and this is the part 6 of chemical kinetics chapter. So now what we are going to discuss about this video, we are going to discuss about the rate law, rate constant, units of rate constant, and characteristics of rate constants we are going to be discussed. Okay, first let us see the rate law. So here what is the rate law? So before knowing about the rate law, once let us recap the rate of reaction. So what is the rate of reaction? Rate of reaction. What is the rate of reaction, children? Rate of reaction means the change in concentration by change in time. That is known as what, children? Rate of reaction. Change in concentration. Change in concentration by change in time. Change in time. That is the rate of reaction, ROR, rate of reaction. So for an hypothetical reaction, consider A is gives rise to P product. How we write the rate of reaction? Rate of reaction we write, that is minus dA by dt, that equal to dP by dt. dP by dt. The rate of reaction we know. Right? Now what is the rate law? What is the rate law? So here rate law gives relation between rate of reaction and concentration of reactants. So rate law or rate equation rate equation or rate expression rate expression okay rate expression, it is gives information about relation between rate of reaction and concentration of reactants. So rate law or rate equation or rate expression gives information information about the rate of reaction and concentration of reactants, about rate of reaction rate of reaction and concentration of reactants concentration of reactants according to rate law or rate expression or rate equation. Rate of reaction is directly proportional to concentration to the power n. Okay, this is the rate law or rate expression. And here to remove this proportionality, here we are going to keep a constant, that is k. So rate equal to k into concentration to the power n. Okay, so now here rate is nothing but rate of reaction, and what is the k? K is called rate constant. K is called rate constant or specific rate of reaction specific rate of reaction specific rate of reaction okay, and or velocity constant, or one more also it is there, that is velocity constant okay, right. Next, what about the n? What is the n here? So here n is equal to order of reaction, n equal to order of reaction. So here what is the meaning of order of reaction? Order of reaction is nothing but what, children? the sum of powers of stoichiometric coefficients. The rate equation is called what? Order of reaction. How we are going to define the order of reaction? The sum of powers of concentration terms. Sum of powers of concentration terms. Concentration terms. The sum of powers of concentration terms in rate equation or rate expression or rate law is called what, children? Is called order of reaction. Okay, is called order of reaction. Order of reaction. Okay, so now let us take an hypothetical reaction, that is A moles of A plus B moles of B is gives rise to product. Consider, okay, say A moles of A plus B moles of B are going to be combined and they give us product. And for this, how we are going to write the rate expression? Rate expression that rate equal to, or rate law, how we are going to write? Rate is equal to K into concentration of A power X, concentration of B power Y. Concentration of B power Y, where X plus Y is called order of reaction. Okay, order of reaction, which is indicated with the n. Order of reaction which is indicated with the n. So therefore, X plus Y equal to n. This is the order of reaction, and where X is the order with respect to A and Y is the order with respect to B. Okay, so here what is the X, children? X is equal to order with respect to A, and Y equal to order with respect to B. The about order of reaction. So here X and Y may be equal to stoichiometric coefficient or may not be equal to stoichiometric coefficient. So here X and Y, these are may be equal to this stoichiometric coefficients A and B, or they may not be equal to the stoichiometric coefficients A and B. Okay, so now here what we can write, X comma Y, or maybe X comma Y may be equal to its stoichiometric coefficient or may not be equal to stoichiometric coefficient in the balanced chemical reaction. Okay, XY may be equal to may be equal to stoichiometric coefficients. Stoichiometric coefficients, stoichiometric coefficients, or may not be equal to stoichiometric coefficient. May not be equal to stoichiometric coefficients. Stoichiometric coefficients in balanced chemical reaction. Okay, let us take some example in which the X and Y or the power values are equal to stoichiometric coefficient, and some more examples in which the power values are not equal to stoichiometric coefficients. For example, you take the decomposition of HI. Okay, so 2HI is gives rise to H2 plus I2. So now here what is the rate equation for this? Rate equal to K into HI power 2. Rate equal to K into HI power 2. So here the power value is equal to what, children? Stoichiometric coefficients. And here you can take one more example. Let us consider 2NO plus Cl2 is gives rise to 2NOCl. 2NOCl. 2NO plus Cl2 is gives rise to 2NOCl. So now here rate equal to K into NO square is NO power 2 Cl2 power 1, and in this equation also these stoichiometry these power values are equal to stoichiometric coefficient. So here what is the NO power 2, and it is only the stoichiometric coefficient of NO, and what is the stoichiometric coefficient of Cl, that is 1. So here power value is also 1. Okay. So in these reactions the power values are equal to what? Stoichiometric coefficients. And let us take some more examples in which the power values are not equal to stoichiometric coefficients. Say for example, you take or else one more example you take. Okay, take this CHCl3 plus Cl2, CHCl3 plus Cl2 is gives rise to CCl4 plus HCl. Consider this reaction. So for this reaction, rate equal to K into CHCl3 power 1 and Cl2 power 1 by 2. Cl2 power 1 by 2. And here, when you observe very carefully, HCl3 power 1, this is only the stoichiometric coefficient, but Cl2 power 1 by 2. But here, what is the stoichiometric coefficient? 1. So means here 1 by 2 is not equal to stoichiometric coefficients. And you take one more example, that is CH3 COO C2H5, CH3 COO C2H5 plus H2O, and here it gives rise to CH3COOH plus C2H5OH. So now this is the reaction. So for this rate equal to K into CH3 COO C2H5 power 1, but here H2O power 0, H2O power 0 means here the concentration of H2O will not affect the rate of reaction, and concentration of ethyl acetate only going to affect the rate of reaction. Means here 1 we are going to take, but here 1 is there, but here 0 we are going to take. Okay, so this is the rate law for the these reactions. So now you can get the doubt, sir, how you are writing these rate equations or rate expressions. These rate equations or rate expressions are written by using the experimental data only. Simply by seeing a balanced chemical reactions, we cannot write the rate expression or rate equation. Then how we write these rate expressions means these rate expressions are written by using what, children? Experimental data only. And the order of reaction also we can find out by using experimental data only. Okay, so here one of the main important point, so mi star or main important point you consider. So here rate of reaction and rate law and order of reaction can find by using experimental data only. Okay, so here rate law or rate expression and order of reaction we can find order of reaction we can find by using experimental data only. You can find by using experimental data only. Experimental data only. Experimental data only But by seeing simply a balanced reactions, we cannot write the rate equation or rate expression. But for single step reactions, means elementary reactions. Single step reactions or elementary reactions, the reactions which completes within only one step, they are called elementary reactions. For elementary reactions, we can find or we can write the rate law by using the balanced chemical reaction. But how we can say that is a single step reaction? By doing again experiments only, which means indirectly or directly what we are going to say here, the rate law and order of reaction we can find by using what, children? Experimental data only. But by seeing simply a balanced chemical reaction, we cannot write the rate law and order of reaction. It's about the order of reaction and rate law. Next, one more thing, that is rate constant. Okay, in the rate law we are having, so rate law, the rate law. So rate law is what, children? Rate equal to K into concentration to the power n. So here K is called what, children? What is the K here? Rate constant or specific rate of reaction. K is called rate constant. Rate constant or specific rate of reaction. Okay. So if concentration of reacting species is unity, if concentration of reacting species is unity, so then rate equal to k into 1 power n. So any 1 power n is again it will become 1 only. Therefore rate equal to rate constant. Rate equal to rate constant. So now here rate equal to rate constant. When the rate equal to rate constant, it will become, the concentration terms will become unity. Okay, if the all reacting concentrations are become unity, means rate equal to rate constant. And here one more thing about the rate constant, that is units. What are the units of rate constant? Units of rate constant. Units of rate constant. So here what are the units of rate constant? Okay, how we can find the units of rate constant? So units of rate constant, just to write the rate of reaction. So rate equal to K into concentration to the power n. Rate equal to concentration to the power n. So here what is the rate formula? Rate is nothing but change in concentration by change in time. Okay, what is rate, children? Change in concentration dx by dt, that equal to K into concentration to the power n. Okay, rate equal to K into concentration to the power n. Therefore what is the dx? Dx means change in concentration. Okay, again here what we are going to get here? Concentration. dt means what? Change in time. Change in time. Okay, so time inverse, time units, that equal to K into concentration to the power n. Therefore K equal to what, children? Concentration by time into concentration to the power n. Okay, so now you just rearrange this, what you will get here? Concentration into, so numerator concentration, and the denominator concentration we are going to take into the numerator. Okay, so concentration to the power minus n into time inverse, time inverse. Okay, so now here concentration to the power 1, concentration to the power minus n. So therefore K will become, okay, so now K equal to concentration to the power 1 minus n time inverse. Concentration to the power 1 minus n time inverse. So these are the units of K. Okay, so this concentration sometime will take the molarity, means moles per liter, and sometime will take the partial pressure. Okay, when we take the partial pressure, children, when we are having the gaseous reactants and gaseous products. Okay, when we are having gaseous reactants and gaseous products, we are going to take the partial pressure, and in other cases what we are going to take molar concentration. Generally we will take the molar concentration. See, for example, okay, so we know what are the units of K, children? Units of K equal to, that is concentration to the power 1 minus n, that is, and time inverse. Okay, so now here sometime what I am telling children, concentration, if concentration equal to moles per liter, means molarity concentration we are going to take. So therefore K equal to moles per liter to the power 1 minus n time inverse. Okay, so now you multiply into the bracket, so what we get, mole power 1 minus n, liter power n minus 1, here minus 1 into 1 minus n, it will become n minus 1, and time inverse. Okay, time inverse. Okay, so this is about the units of K. And if, okay, if concentration equal to pressure, pressure or partial pressure, pressure. So what are the units of pressure, children? You can take the atm or bar. Therefore K equal to what is the units of K? So now here atm power 1 minus n time inverse, atm power 1 minus n time inverse. Okay, these are the units of K. Okay, these are the general units of K. So here when we use these units, children, when gaseous reactants and products are present, when gaseous reactants are there, when gaseous reactants, when gaseous reactants are present, are present, when gaseous reactants are present, we are going to take this relation, and remaining cases we are going to take the this unit generally. Okay, so next let us observe the some type of reactions. Okay, type of reactions we can classify based on the order: first order reactions, second order reactions, third order reactions, and zero order reactions. Okay, so this is about the nth order reactions. Okay, this is what nth order reactions. Okay, what are the general units? Concentration to the power 1 minus n time inverse. Okay, so when the concentration is expressed in the moles per liter, when the concentration is expressed in moles per liter, what we are going to get, children? Mole power 1 minus n, liter power n minus 1 per second, already we discussed. And for gaseous reactions, atm power 1 minus n, and second inverse, here second is nothing but time inverse. Okay, so now you see the first order reaction. First order reaction, what is the meaning of a first order reaction? N equal to 1. Okay, so if you substitute the n equal to 1 here, what will become? 1 minus 1 will become 0. Anything power 0 is equal to 1 itself. Therefore only time inverse remains for the first order reaction. And here what are the units? Second inverse, and here also in case of gases also you can get the second inverse. Second order reaction. So what is the second order reaction, children? If n equal to 2, that is the second order reaction. So now you substitute that values here. So 2 you substitute, 1 minus 2 minus 1 time inverse, means concentration power minus 1 time inverse you will get. Okay, or else moles power minus 1 liter. Okay, 2 minus 1 1 liter power 1 second inverse, and here 1 minus 2 means minus 1 atm power minus 1 second inverse you will get like that. So now if n equal to 3, n equal to 3, here you substitute the n equal to 3. If you substitute the n equal to 3, 1 minus 3, that is minus 2. Okay, concentration power minus 2 time inverse. Okay, so if you substitute the same value here, 1 minus 3, 1 minus 3, that is minus 2, moles power minus 2, 3 minus 1, 2 means liter square second inverse, as it is we are writing, and atmosphere to the power minus 2 second inverse. Next, if zero order reaction means children n equal to 0. Okay, if zero order reaction means what? n equal to 0. So in case of n equal to 0, concentration means 1 minus 0 is 1 only, concentration power 1 time inverse, concentration into time inverse, and here mole 1 minus 0 0, so 0 minus 1 minus 1 liter power minus 1 per second, and here atm per second. So this is about the rate law or rate expression, and what is the order of reaction, and what are the units of K. And finally we are going to see characteristics of rate constant. What are the characteristics of rate constant? So characteristics means, children, simply you remember K depends on what and K independence on what. K depends on, depends, K depends on, K depends on temperature. Okay, so temperature is directly proportional to rate constant. Means temperature increases, rate constant also increases. Next to rate of reaction, rate of reaction, K is the direct measure of the rate of reaction. If more K value, more the rate of reaction, less the K value, less the rate of reaction. Okay, and you can take the activation energy. Okay, activation energy is inversely proportional to K. Activation energy is inversely proportional to K. More activation energy, less K value. Okay, or less activation energy, more K value. And okay, these are the major factors. Next, you can take the catalyst also. Catalyst. Okay, catalyst also can affect the rate constant. For example, positive catalyst. Positive catalyst is directly proportional to the rate constant, and negative catalyst is inversely proportional to the rate constant. Okay, so these are the factors which affect on the rate of reaction. And one more important here, K depends on type of reaction also. K depends on what, children? Type of reaction also. If you change the reaction, rate constant value is also going to be changed. Why? Because here K is not an universal constant. Okay, have to remember K is not an universal constant. It is a constant for a particular reaction only. Means if a reaction changes, rate constant value is also going to be changed. Therefore, depends on type of reaction. Type of, okay, type of reaction means reaction changes or reactants. Okay, type of reaction or reactants also you can consider. Reactants, reactants, type of reactants. This reactant changes, rate constant also is going to be changed. And next, K independent on, K independent, K independent, 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 independent depends on, independence on concentration. Okay, so for a same reaction, whatever the concentration you take, for the same reaction, whatever the concentration you take, rate of reaction is always constant. You can take different initial concentrations also, rate constant is not going to be changed. For example, so here A to B, we are doing a reaction with 0.1 mole of A and 0.2 mole of A or 10 mole of E. Also, how much you take also, rate constant is not going to be changed for a particular reaction. Okay, so means it does not depend on the concentration, and it does not depend on the time also. It does not depend on what, children? Time also. Okay, this is about what, characteristics of rate constant. Okay, right. So what we have discussed so far, we discussed about what is the rate law. Okay, what is the rate law we have discussed. It gives relation between the rate of reaction and concentration of reactants. And next, what is the order of reaction? Okay, what is the order of reaction? This is the sum of powers of concentration terms, that is the order of reaction. So the order of reaction we can find out by using experimental data only, and also rate equation or rate expression also we write by using the experimental data only. And next, specific rate constant. What is the rate constant? So rate constant is nothing but to remove this proportionality, we'll keep the rate constant. Okay, and rate constant is also called specific rate of reaction. When the concentration terms become unity, rate equal to rate constant. And what are the units of K? We have derived. And K, general units of K, when we take the molar concentration, general units of K when you take the partial pressure. Next, we discussed about the some table about the different order of reactions like first order, second order, third order. What are the units of K in different order of reactions? Next, we discussed about the what are the characteristics of rate constant. This is about the about total about this video lecture, and finally we arrived end of this topic. Okay, thank you for watching. If you like our efforts and our work, please subscribe our channel and you recommend it to your friends. Thank you for watching.